So hi Brett, it's lovely to meet you here at the Codasip stand at Embedded World 2023. Let's start by explaining a little bit about what Codasip does.
Great, thanks Stuart, we appreciate it. Codasip's a company that was founded in Europe. We're headquartered in Munich. Our R&D resources are entirely in Europe, and we're focused on the RISC-V and RISC-V ecosystem. What we do is we provide RISC-V IP to our customers, as well as tools that help them enhance and customize RISC-V to improve their differentiation in the market.
Now that's one of the most exciting things I think about RISC-V is that customization capability. If we look at the ISA, there's that lovely gap in there where we can put our own instructions, but it's not an easy process, is it? Tell us how do you help people do that and get it right?
Sure. Traditionally, a number of the microprocessors that are out in the market only allow you to use their instruction set architecture or their ISA as is. RISC-V, as you mentioned, is an open standard, and while there are open source aspects to it, the open standard allows people to go off and build custom instructions or customize their processor to do things that are unique for their software workload. The challenge with it is that if I've customized my hardware, I then have to have an entire software tool chain that supports that customization. So what we do at Codasip is we provide a tool called Codasip Studio that allows you to quickly and easily modify or even build your own RISC-V from the ground up. And then as the output of the tool is not only the hardware design kit, which is your Verilog, UVM environment, and vectors and things for verification, it's also the entire software chain. So we give you the compiler, a custom debugger, custom profiler, and all the tools that you'll need so that your software now can use those custom instructions automatically.
So that means that if I'm starting to develop some new assembly instructions in the instruction set, am I then able just to write C code which will understand when to use those instructions, or are we just talking about inline assembler support?
It's a great question. So automatically our compiler will pick up your new custom instructions. You can, of course, at any time write assembly inline, but that's a little bit old school, but sometimes you need to for performance reasons. But in general, the compiler will pick up these automatic custom instructions.
So take us a little bit through the process of designing custom instructions. There might be, I don't know, let's say a multiply and accumulate of say like 8-bit data or something that we really want to accelerate. What's the process for your customers as they're using the studio to firstly develop it and then make sure that instruction does what it's supposed to do?
Yeah, that's a great question. So what happens is you might be using our L31 processor, which was an award-winning Embedded World one last year, and the first thing you would do is you'd profile your code. So what we want to know is how does your software workload work on the processor? And so with your software workload, we'll run through it, and we might find there's a hotspot in there. And the hotspot, the engineer might determine, wow, if I just had an 8-bit multiply accumulate, I could go ahead and eliminate a bunch of code from my source. So what you can do is you can go off and you can model first at an instruction accurate level. You can model that instruction, and you can do some architectural exploration to find out, does it really solve my problem? And what's the performance improvement, or what's the reduction in the number of lines of code? Over time, what you'll do then, once you've decided on what your custom instruction looks like, you'll refine that down to a cycle accurate level. And the cycle accurate is ultimately what you're going to build in RTL. And so the tool allows you to do all these things, create all the compilers along the way, do the exploration, and then ultimately refine it down to something that will build your very own RISC-V RTL processor.
Now RISC-V, for people who, many people have heard of the term and understand the buzz behind it, but I mean, what sort of range of different processors are available from someone like yourself that are RISC-V based? What are the options? How are they different to each other?
Sure, it's a great question. So one of the things that we start with is the embedded cores. We've got a full lineup of embedded cores that you could use today as is, or you can customize them to go forward. We also have mid-range embedded, and we also have application cores. So it really is anything that runs up to what runs Linux, or an RTOS, or bare metal, however you'd like to do it, in the full range of different processors. Over time, we'll continue to expand that line and target different higher-end markets.
What are the key applications that you're seeing today that are saying, yeah, we see value in RISC-V and also developing our own chip, which is a big commitment. So,
sure.
You know, who's doing that today?
It's across the board. I mean, there's no one application. We've seen things from wireless to camera applications to security applications. And one of the great things about RISC-V, especially if we allow you the ability to customize it, is you can start to figure out what pieces go together. So it might be an AI application that needs some security, or maybe it's automotive that by definition needs security and safety. So really you can do anything with the RISC-V part. I think what you're seeing mostly is people are starting off with the low-end ones as they start to replace other parts that are in their system, because the risk is lower for them. But certainly people want to go the long run, which is the full application level processor.
Super. Well, thanks ever so much for giving us that overview on RISC-V and its configurability. It's a very exciting area that we'll be continuing to talk about in the future.
Great, thanks Stuart, appreciate it.